Alright, so right now I'm gonna do a demonstration of the full process of how we would pre-process the dataset from WSP and prepare it for modeling in Graphab. Okay, so the first thing I would like to do is I would first prepare my folders. So since we've been doing this multiple times, so I already have a folder format that I would follow. It's you're not you don't have to follow this exactly, but this is what I usually like to do. So I would have my folder for copy, which includes the pre-process subfolder and also the uh, model inputs for Graphab and CircuitScape. I guess we're not doing it this time around, but it's also in the same folder. And for each of the species, I like to keep their files in their individual folder. So since we're working on the spotted tail wall, right now I'm just gonna copy the folder and paste it here. And I will rename it to the species that I'm working on. Okay, so once that is done, I'll just check if all the folders are available. Alright, and the next thing that I would like to do it for each project is set the environments. So if we go to analysis and the environments, here I would make sure that the output coordinate system is set to the one that I'm using. So in this case, it's the Australia Albus. And for the extent, I will make sure to set it to a specific layer that I'll be using for all my species and all the processing. In this case, it's the land cover for snap. So, okay, I can't select it. So if you see here, I have this layer available, and this is just a blank raster layer that I have set, which includes the columns and rows that are fixed for this whole project. And as you can see, these columns and rows should be in line with the file sent by WSP. And the cell size also is set to 20. Okay, so I will go to the environments and make sure my extent is set to that layer, G2H, and for the mask as well, and the snap raster. So these are the settings that I would make sure to check every time I run the tools in ArcGIS. Okay, once that is sorted out, the next thing that we'll do is we will copy the layers that we've received from WSP, which is the resistance, the gap crossing, and the habitat. So I will put it in this subfolder, file sent by WSP. Okay, so just a quick check to make sure that the layers are in place. Okay, all right, so the first, we'll move on to the first pre-processing activity, which is the gap crossing layer. So in this case, it's this one. So now the values that they have is 0 and then 1 for the gap crossing. So before we can proceed, we first want to reclassify the values. So if we go to geoprocessing, so I have my history ready. I'll just go to the reclassify. And here I will set the gap crossing in the input raster. So the gap crossing from WSP will be the input raster. And reclass field is value. So here I'll click unique. So this will generate the values that are available in the raster layer. And I will reclassify it to no data, and 1 will remain as 1. Make sure that sometimes if you, let's say, key in a value and then you click elsewhere, the value will not be accepted. So make sure to type, just click enter to make sure that the value that you've inputted is incorporated. And also, I like to check this change missing values to no data. So this will ensure that any other values, if it's available in this raster, will be changed to no data. And for the output raster, I'll just make sure that I set it in the right location. So in this case, it's in my pre-process folder for spotted tailed quail. And for the layer name, I'll make sure to change it to spotted tailed quail. If you're doing this for the first time, obviously you would have to navigate to the folder that you want to use. So in this case, I'm using the one here, pre-process, and then this is the location. Okay, once that is done, please check the coordinate system, the extent. Just make sure that it's set to the land cover, the layer that you want to standardize. The mask and the snap raster should be the same. Once that is done, click run, and you should have your new layer now. And as you can see, the value left is just the pixel value 1. And it should overlap exactly with the layer from WSP. So if you can see, it aligns perfectly. So this is why it's important to make sure to snap the raster and set the extent and mask. All right, once that is done, I'll move that to the pre-processing. And also make sure to save your file as you're working, so that if in case it crashes, nothing will be lost. Okay, for the next step, we're going to buffer the gap crossing layer. So if you remember, the gap crossing has to be buffered to be at least half of the gap crossing threshold, at least or more than half of the gap crossing threshold. So in this case, for spotted tail quail, the gap crossing threshold has been set to 500 meters. So we've tested out a few distances. So if you look at this one here, let me turn that off real quick. Okay, so if you look at the black one is the gap crossing for spotted tailed quail, and the yellow is the buffered gap crossing layer. So if you see here, we'll pick a spot where there's a single gap crossing pixel, and for this exercise, for this tool, the purpose is to make sure that we buffer the gap crossing to at least half or more than the gap crossing threshold. So in this case, it's 500. So we want to make sure that half of 500 is about 250. So we want to make sure that the buffer will cover at least 250 and above. So if you can see here, it's all, the shortest point is at least 255, which is more than half. If it's any lower, for example, 276, it will be too short. So here you can see it's 249, which is less than the 250, slightly less. And yeah, so that's why we're going with the 279 version, to make sure that everything is past the minimum threshold of half. All right, so this process usually takes a long time, but we've already tested quite a few distances. So that's why we're using this as our buffer. Okay, so in this case, let me just turn this layer off first and turn this back on. All right. So here for the input raster, we're going to insert our spot tail quail the reclass, which is this layer that we just generated just now. And let me set the output. Okay, it's the same folder, and I just want to make sure my layer name is, my output name is spotted tail quo reclass, and Euclidean distance, I will put the distance that was set just now, so 279. All right, and for the output cell size is 20, and check the environment. Okay, if it's all good, I'll click run. All right, so now that's out, I'll put it to the pre-processing again. And before we check, we just need to run one more step, which is to reclassify all this value. If you can see here, 0 to 278, we want to reclassify all this value into a single value. So we will use the reclassify tool again. Drag this into the input raster, the Euclidean distance output. And instead of clicking unique, because there's many values here, if you click unique, it will be a very long table. So what I like to do is I'll click classify. Oh, sorry. Okay, yeah, that should work. Classify, and then I'll set it to 1. So yeah, so this is the highest value. Okay. And you can see that the highest from 0 to the highest value, it will be set to 1, and the rest will be no data. Again, check the change missing values to no data, and put specify your output location and file name. Remember, this is 279. Okay. Okay, the output is out, and you can see that now all the values has been converted into a single value 1. And if we want to check it against the reclass value, so let's drag it here. And you can see, okay, let me just put this to black. Okay, so you can see that the buffer value has been set. It should be the same as just now. So it should be, sorry, it should be at least half or more than the gap crossing threshold. There you go. Okay. Yeah, that looks good. Okay. And note that the reason why we measure it across the whole angle at different angles is because in Graphab, the species will be able to move in the queen's if you play chess, it's like the queen's movement. They can move top, bottom, left, right, and also at the angles. So that's why we want to make sure that the gap crossing is buffered thoroughly at all angles. Okay, so that is done. And now we will move on to the next layer to preprocess, which is the resistance layer. So let me move this back here and turn this off real quick. So now we'll be processing the resistance layer. And for this, the first step we want to do is to make sure that in order to standardize all the layers from WSP, we want to make sure that the layers are synced with the other layers that we have pre-processed so far. So for this step, it's more of a precautionary step. We can actually just use this layer directly, but just as a precaution, we want to make sure that there are no additional values, and also the extra values are set to no data. So for this case, we will put the input raster into the reclassify tool, and then we will click unique. So if you can see here, there's 5 values. So if you click unique, all the 5 values should be generated. And here we just want to make sure that we copy exactly the values from the input raster. Again, I click enter every time I type so that the values are correct, accurate. Thank you. Okay, so just to quick check and set the output, location, and layer name. All right, and the environments should be the same. Okay, and then I'll click run. So yeah, the output should be exactly the same as the input. All right. Okay. So once that is done, what we're going to do next is to create a final resistance layer. We actually want to clip this resistance layer to the buffered gap crossing. So in order to do that, we're going to use raster calculator. So, and this is the formula that we usually use. So it is the buffered gap crossing layer multiplied by 0 plus 1, and this will be in bracket, and then we multiply this by the resistance layer. Okay. Here I will replace it with the spot tail gap crossing. Okay, so we just double click on the layer and it will appear. Okay, and then I will replace this one with the resistance layer. All right, so let me just set this, and then you can see what the output will look like. Again, check the environments and mask and snap. All right. So now to double check, you can drag this under the buffered resistance. So if you can see here, now everything that is outside of this buffered gap crossing layer will be omitted. So if you see, the resistance has been clipped to exactly the buffered gap crossing layer. Okay. All right, let me just save that real quick. Okay, so after checking, we would like to make sure that for Graphab, it's very sensitive to the no data value. Hence, instead of using this directly, we usually copy the raster and set the no data value to 9999. So this would ensure that all these values that are supposedly no data will have a value of 99999, so that Graphab won't consider that value at all, because the resistance is very, very high. So here we will put the generated resistance as the input raster and set the output location and layer name, and no data value set to 9999, 5 nines, and pixel type is 16-bit unsigned and TIFF format. For the environments, it's as usual, just set the extent For this case, there is no mask, but just make sure the snap master is the same and the coordinate system. Okay, click run. All right. So now we should have these two available. So right now we will process the final layer from WSP, which is the habitat layer. So in this case, I would go back to the classify tool. Hold on, let me, yeah. Yes, okay, correct. So the next one, we're going to reclassify the habitat. And this one, again, is a precautionary step. And also because we want the values to be 1 and 2 instead of 0 and 1. So we'll drag this in and click unique so you can see any value that is currently 0, we want to make sure that it's set to 1. And this will be explained when we run Graphab. So we make sure everything that's 0 is 1, anything that's 1 is 2. And the rest will be no data. So let me just set the output. All right, and click, sorry, unable to open. All right, okay. So because this tool was run at a different map, so right now I just need to drag it in again. And cover for snap. Oops, sorry. And for the mask and snap raster. Okay. What's wrong? And what's wrong? This is another bug. Okay, that's weird. Let me just save. So I have my layer here, just in case. There you go. Okay, so sometimes there's a bug and maybe it doesn't want to read. So it's good to navigate to the original location of the file. So in this case, I've put it in the all species folder. So this is the layer that I would use. Okay, so once that's done, just check it against the original and make sure that it's accurate. Yeah, change it. Yep. So it snaps with the original. It's just that now the values have been reclassified from 0, 1 to 1, 2. Okay, I'll put this in the Graphab outputs. And we're done. Okay, so this tool will be the input for our Graphab model. So before we start running Graphab, please make sure that you close the ArcGIS. And we'll continue in the next video.